Hello and welcome to CS264. This is lecture 10 and this is lesson 2. In this lesson I'm going to talk about LINQ and anonymous types. We've seen examples of these already. We've seen examples on anonymous types, and we've seen me use LINQ examples or LINQ queries that return anonymous types. So I thought it would be a good idea to summarize what we know in just one place. So first let's have a look at what we know about anonymous types. So remember from our documentation and from earlier lessons, we saw that anonymous types provide a way to encapsulate a set of read-only properties into a single object without having to explicitly define a type for that object. We saw them used with var, for example. The type name is generated by the compiler and is not available at the source code level, and the type of each property is actually inferred by the compiler. So you can create anonymous types using the new operator together with an object initializer. Anonymous types contain one or more public read-only properties, and no other kinds of class members like methods, events, etc. they're valid in the anonymous type declaration. The expression that's used to initialize a property cannot be null, it can't be an anonymous function, nor a pointer type. So here's one, for example. Let's say we created an anonymous type called department, and here we see it has we use new, as we said already. There are three properties here, and the default values are computer science, and the faculty would be science and engineering, and the building is the oldest building. Okay? And we can write and access the information contained within that property or the fields as we normally was, using the dot notation, department.name, department.faculty. And these attributes or these fields, they're not too different from the XML descriptors that we had in the last lesson, for example. So anonymous types then are used in the select clause of the LINQ query expression. It returns a subset of the properties from each object in the source sequence. So the most common LINQ scenario is to initialize some anonymous type with properties from another type, and you can see this referred to as a projection. Okay, we talk about the LINQ projection. That's what's actually happening here. So in the program demo that I have below, we can see that if you don't specify member names in the anonymous type, as we did earlier up here, okay, then the compiler gives the anonymous type members the same name as the property that's being used to initialize them. You must provide a name for a property that's being initialized with an expression, however, as we've seen above. Okay. In this example that follows here, we've declared an implicitly typed array. So there's no square brackets are used on the left side of the initialization statement, and the jagged arrays are initialized using the new square bracket, just like single dimension arrays. And implicitly typed arrays, like we have here, are typically used in query expressions together with anonymous types and object and collection initializers. Finally, when you create an anonymous type that contains an array, as we have here, so this is the first one here, and when you have an anonymous type that also contains an array, the array must be implicitly typed in the type's object initializer. So departments is implicitly typed here. It's an implicitly typed array of anonymous types, each which contains an array named courses, and we don't need the var keyword used inside the actual object initializer. So if you see here, we have var departments as a new array of anonymous types, and then we create each anonymous type, object here, but we don't need to say var again. We don't say var courses equal to new, okay, as we've done here. So here are three departments that have been created, and for example, they have a name, a faculty, a building, and the courses that they offer. And then we can choose a query. Again, we use var, almost always use var to create a departmental query from department in departments. So this is the source departments, and the department or DPT will be the one that we're going to iterate over as part of we make the query. Then we extract the name and the building here. And you'll notice that when we created this anonymous type, we didn't have to explicitly say the name of the attribute or the name of the field. It will pick up name and building, and we know that because when we print, we can use name and building, and it'll work just fine for us. Let me switch to here and see if we can get some code that shows this. I see something called myanon. Okay, so let's look at that one. Let's go back up a directory, cd myanon. So we should have recorded this one here. Yeah, it looks like it's this one here. Yeah, okay. And I created a public class here anyway. Okay, that's a defined type. It's not an anonymous type. Okay, yeah, here's our department, our anonymous type. We're printing the details. Here we have departments, printing the details. And we're iterating over this and printing it. Okay, now I'm doing some other work here that I'll talk about a little bit later. Okay, so let's get the first part of it running and be sure it works. Be sure it works as we expect. Okay, so that's just fine. That's exactly how we expected it to work. Okay, let's go back to the lesson. So when we use anonymous types, it's important we don't misuse the anonymous type. It's a great idea to use them in your LINQ queries, but don't use anonymous type instead of classes in your programs. Remember that attributes of anonymous types are read-only properties. Okay. Anonymous type allows us to create and instantiate it quickly without having to declare type earlier, which is fine within LINQ queries, but not for ordinary coding that require designs, and designs are paramount for us. Usually, also, it's not recommended to pass or return an anonymous type as a method parameter or to return an object, as a return object. Handling it as an object is quite tedious. In these cases, it's preferable to use a class or a struct type. You can do this. I'd advise not to do it. But that said, you do it a bit like this using reflection. Okay, so you could print the anonymous values. So you could pass through an anonymous type and get the properties here, and get the type using reflection. Get the properties then of that. Information from the type, and then iterate over the properties and just get the information. Now you can do it that way. Okay. So we've been looking at anonymous type using LINQ from anonymous array type, and that was just to give some experience of the anonymous types. They work with links. We work with lists of objects, and we use the same approach that we had earlier. So here's this example, that the full program here, and you can see I've created this department class, which is essentially equivalent to these, and I can iterate over those and play with those. So we can go back to the code and have a quick look. So this was, I did some reflection on the department, so I created an anonymous array, a query earlier, and I was able to, I can just, let me go back up and see where the department was. Yeah, we created this early on in our program, and now we can actually pass that, and I'm advising we don't do this, to this print anonymous values department, and we can use reflection to be able to look at this. So what I've done actually is I've created here, I've used the department class to create a list of departments. Okay, so essentially we're creating this object here, this array of anonymous lists, which are fine. Generally, as I said, we return these from the LINQ query as we've done here, okay, but not generally for creating lists of things. So what I've done is I've actually created it properly here using a list of classed objects that have defined class, and then I do a search where I iterate over this departments. Again, same type of LINQ queries we had beforehand. So we're creating a new anonymous array that we're returning, and we're explicitly giving it a name now. Okay, a name and building capital L and capital B. So it differs from the name that we would take from the object that we're querying. And I iterate that, and it's fine. So we get the exact same results as we would for the earlier example. And again, this is just the method that I had created, a static method that prints out the values of an anonymous object. Probably not a good idea to do it, but we use reflection to look at this. And this is why we are referring to reflection up here, loading that namespace. Okay, let's look at the rest of the program. And you can see that the reflection worked. It was able to query the department object, and again we were able to work through the anonymous type returned from the list of departments in much the same way as we were able to play with the array of anonymous objects here as well. Okay, so we learned a little bit about using anonymous types, how to process anonymous types that are returned from LINQ queries in C#. And there's a couple of guides here, how to project anonymous types in LINQ, and the anonymous type programming guide from Microsoft. Thank you very much for watching.